Welcome back, and thanks again for joining our webinar series, Digitize for Design and Inspection. Indicate Technologies is hosting this webinar series. Our company is a leading supplier of equipment and services for additive manufacturing and precision dimensional measurement to the high technology industries of the Western United States. Recently, we've seen a number of exciting developments in the 3D scanning technologies and related software tools. This particular video segment is one in a series of webinars designed to highlight what is possible with these new tools. Each of the 20-minute segments will present a scanner and a software demonstrating a workflow for a specific result related to either reverse engineering or inspection. This particular segment includes digitizing a building with the Artec 3D Ray LiDAR scanner and reverse engineering it using Geomagic Design X. The workflow we're targeting will illustrate efficiencies in 3D scanning and CAD rendering that are unique to extremely large data sets. In this particular case, we will scan a portion of the outside of a building and reverse engineer that using the Design X tool. When you came onto the webinar, each of your audio lines was muted, so we won't be able to hear you within the context of the webinar. However, you can submit questions by pushing the Q&A button on your screen, and at the end of the webinar, we'll get to as many questions as possible. Those that we don't or are not able to answer in the webinar, we will get each of those responded to. So anybody who raises a question or an issue, we'll get a response from us, and then we'll additionally make all the frequently asked questions available on the recorded version of the webinar and send those out to those who registered. So let's see. Thanks for joining us today, and we're going to pass this on now to Anton Bosniaga of Artec 3D, who will introduce the scanner and scan the building. Anton, take it away.
Hello, I'm Anton from Artec 3D here with Indicate Technologies, and today we're going to take a look at the Artec Ray LiDAR scanner. Now, before we do anything else, let me start the preview on the scanner. This basically is the process that allows us to see through the scanner's lens to identify features in the environment that we want scanned. So now that this has started, let's talk a little bit about the device. This is Artec's LiDAR scanner. It has a range of 110 meters or 120 yards, so roughly the length of a football field. So if you're standing at the goalpost, you'll be able to see all the way to the other side of the field. Of course, it can scan that vertically as well. It has a viewing angle of 360 degrees around itself and 270 degrees vertically. So 360 degrees horizontally, 270 degrees vertically. At the maximum point density, at the maximum accuracy level, it'll scan at 700 microns, so that's the error on the device. There's also a high sensitivity mode, which allows you to scan shiny reflective objects or objects that are noisier, but with a slightly reduced accuracy of 900 microns. So even at its worst, it still delivers sub-millimeter accuracy. Let's check a little bit on that preview. All right. Still have a little bit to go. Now, when the device finishes with the preliminary scan, we're going to have a view of the environment around it, of all the 360 degrees around the device, and we'll be able to choose which parts of the environment we want scanned. Now, in this case, we're going to focus just on that column, and we're going to scan that column in a higher resolution, and we're going to pass that on to our colleagues to be worked on in Design X. Now, the reason why we're not going to scan the entire environment is because if we scan at full resolution, at the best the device can do, at the maximum point density, then it's going to take us just over 30 minutes to complete the 360-degree scan. And if we do a 360-degree scan with a lower point density, which we can actually set in the software, then we're going to get less resolution. So by limiting to just one sliver of the data, just a few arcs a degree, we're going to be able to complete the scan quicker and in higher resolution. So you see the device stop moving. That means that we're done with the preview, and hopefully you can see what I can see here on my screen. We can see the parking lot, some of my colleagues hiding behind the camera, and I'm free now, knowing which direction the scanner is pointed, to choose just some of the features that we want to scan. So I'm using the rectangular selector here to select a portion of the environment, just that one column. You'll see that red area around the column. And here we can play with the points per degree, with the point density. If we increase or decrease the point density, you will see that the amount of time that the software tells us the scan is going to take is changing. At the lowest level, it's going to take us less than a minute. At the higher densities, it's going to take us about 2 minutes. Let's split that in the middle and make it just 1 minute. So this scan should take us about a minute with this point density, 70 points per degree. We're going to click scan, and now the scanner is actually capturing the depth data that we will need for this scan. So LiDAR scanners, as you know, tend to be used for very large objects. The Artec Ray is no exception, so it's made for very, very large objects. But like I mentioned, this is one of those scanners that, due to how clean the data set is, due to the not just the noise levels, but also the accuracy of the device, this data is actually usable in a reverse engineering context. So you could use this data to complement handheld scan data, which is a lot denser and a lot more feature-rich than LiDAR data normally is. And this was deliberate. So this was the intention of the device, to give you a LiDAR scanner that can scan huge volumes, but with the capabilities of a small handheld unit. All right, let's check in on our progress with the scan. You will see that on the screen here, it actually is completing the image. So you will see gradually the data build up, and you'll be able to see what the scanner is seeing in real time. You're not seeing a full color image. It's not a monochrome image either. It's basically a reflection image. It's darker the less light you get from that surface, and it's brighter the more light you get from that surface. So it's not really color as much as it's the light intensity of that surface. Now it's done with the actual data capture phase. It's going to do some pre-processing on that data and make it available to us within Artec Studio. So you see the green bar moving at the bottom, and sure enough, here is our data set. So this is what the scanner captured. Now for very, very large surfaces, depending on how fast your computer is, our software, Artec Studio, may downgrade the quality. But even in this preview mode, sort of the most basic level of data display, you can already see that you can clearly see the brickwork there and some of the features of this column, including you can see through glass, you can see the shades on the second floor. So there you have it. This is our data set. So now this is ready to be handed off to our colleagues to be worked on in DesignX.
Thanks, Anton. Really quick before we get started, I'm going to go up into the preferences and change my units to the correct size. And it looks like I'm looking at the default input scanner unit and the default measure unit. I want to change both these to something larger than what they're normally set at. They're normally set at inches or millimeters. But here, since we're working with the Artec Ray, which is a LiDAR scanner, I want to set them to feet. So both of them are set correctly. So I'll go ahead and go to import. I'll select my file and I'll say import. So here it's given me a pop-up saying that I need to confirm the input scanner units. And it looks like this is a bit too large for a two-story building. So I'm going to go ahead and change that to something that looks a little bit more manageable to me. I'll go ahead and say OK. And then we'll take a look at the data just to make absolutely sure we're in the correct units. So I've got a scale here that this size here is saying it's at 5 feet. And I'll just take a look at the windows and verify that. So pull out a little bit. There we go. So that window is looks like about 8 feet, which is what I'm expecting it to be. And if I take a look at this car piece, this car section right here, that's also about 5 feet. So that seems to be correct. Okay, so before I start reverse engineering this piece, I need to get it in the correct orientation. So really quick, I'll turn off all my planes here, and I'll set down some new planes. So I need to create some that are meaningful to me, and to do that, I'm going to go into plane, and then I'm going to just draw a box in the middle of this plane here, or in the middle of this column. I'll go ahead and preview that. That looks like what I'm looking for, so I'll go ahead and accept that. I'll then use that plane to create my other two. So again, I'll select plane, but this time I'm going to use draw line. And I'm just going to draw right down the middle of that column, all the way to the bottom section. I'll say OK. And then last but not least, I'll do one more draw line, and I'm going to stay right above these, right above this window, and I'm going to use the window as my reference. So right about there looks good. I'll go ahead and say OK. Now that I have 3 planes, I'm going to do an alignment using interactive alignment. I'm going to move to the next step, and then pick my alignment pieces. So this first one is going to be plane 1. My vector will be plane 2, and my position will be plane 3. And actually, I want plane 1 to be in the opposite orientation. So that looks good. I'll go ahead and say OK. And now that I've done the alignment, I don't need these 3 planes, so I'll go ahead and delete these out. Turn on my original 3, and then quickly take a look and see how I did. All right, that looks pretty good. So now to reverse engineer this, I'm going to use the mesh sketch tool, and I'm going to use these planes to recreate this column here. I'm going to start by sketching on this plane here, and I'm going to drag it down into kind of this large area. So I want to make sure I get the outermost points here on this column. So I'm going to use the silhouette arrow, open it up a little bit, and that's going to give me a little bit more data in this area. And I'll zoom in a little bit to make sure that that's what I'm looking for. And it looks like I'm still a little bit above the largest area, so I'll bring this down just a bit. That looks pretty good. I'll go ahead and say OK. Turn this off. And here we have the outermost points of that area. So I'm going to create a rectangle and just kind of encompass this whole area. We'll say OK. Exit the sketch, turn my mesh back on, and then we'll just extrude this like a normal model. I'm going to go up above, I'm going to go up above and below this column. And then I'm going to make 2 cutting tools that are the profile of this column. So go ahead and say OK. So that looks pretty good. So we'll move on to the side profile here. I'm going to use this plane. Again, go back into Mesh Sketch. And actually, I'll turn off my solid. And we can see that that's given me the profile that I'm looking for. If I zoom in here, it's given me all the detail that I'm going to need to recreate this profile. So I'll go ahead and say OK. And I will take a look. That looks pretty good. So my column starts here and it ends down here. So I'm going to go ahead and turn this off. And I can do a couple things. I can auto sketch this feature, which I'll do right here. And that gives me everything that I'm going to need. If I turn this back on, this is the top of the column. We can see that it's done a pretty good job. Obviously, there are some things that we should pay attention to. Maybe this area needs to be fixed a little bit. This maybe should be more vertical instead of at an angle there, and as well as this area here too. So we'll go ahead and do a little cleanup a bit. So I'll go ahead and remove this, and I'll leave what's left. And likewise here, I'll remove here and here, leave what's left. And this may actually be an angle, so we'll go ahead and just connect these two lines here. Escape. And then this area, I'm actually going to trim and do a corner trim. Now you'll notice that these have green endpoints. That means that they're disjointed ends. And what that's telling me is they're not connected and it won't create a closed loop. But when I use the corner trim and select these two areas, it creates a closed loop. It looks like there might be an artifact inside here, so we'll go ahead and delete out any leftover pieces in there. Likewise with this, I'm just going to need to draw a line so I can close this loop off. And again, corner trim away. Same with this area here. Looks pretty good. So this is now a closed area. I still have to close this off. I'll do that here in a second, but we need to deal with this area next. So there are a couple options that we can do here. Instead of auto sketch, I'm going to go ahead and just create a few rectangles. So it looks like I have a rectangle here, rectangle here, rectangle here, 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 and this actually might be a unique feature. So I'm going to have to use lines and arcs, or lines and curves to finish this one. Create a line here, and here, and then we'll try and stay true to this. Looks good. That looks good as well. Then it's just a matter of fitting these rectangles to the correct size. Scoot this out, scoot this over, and just fitting them all together nicely. That looks good. And then all we have to do once we got this done is trim this back. So this usually takes a second, but you get all of the nice coincident markers that you wouldn't anywhere else. So this line's perpendicular to this line, so on and so forth, which is nice. Close that out, close that out. Bring that to about there. Oh, actually, you know what? We'll bring this down a little bit since I know this was scanned from below this area. That's why we have all of these angles here. I'll just click and drag this out a little bit. There we go. Cool. Now I'm going to power trim all the excess away. I don't need anything in the back. And then I'll trim up the pigtails that are left. Zoom in here, good, good. Oh, there's one left, or two. There we go, good. So again, now I have just two disjointed ends left, and all I need to do is draw a rectangle. So again, deleting this area, and this time I just need to corner trim this area, good. And I'll turn on my solid body, good. It overlaps on either side. So once again, turning on my mesh. All I need to do now is exit my sketch. And extrude cut this away. So instead of using blind, I'm going to use through, or through all, and the same on this side here. This cuts all the way through any solid body. So I'm going to go ahead and say OK. And here we have the beginning of our column. We can take a look down here and we can see that we're right in line with our mesh. Okay, so now we need to build the other two sides. And if we take a look, I'll turn off my planes here, that there's many different sizes here, as well on the top, but that's okay. Again, we're going to use another mesh sketch using the front plane. So I'll select the front plane, and this time I'm not going to move it. I'm just going to use the silhouette tool, extrude it out quite a bit. That looks pretty good. And actually, I'm going to pull this down so I get a little bit more information. Perfect. And then it's just a matter of repeating the same steps we did prior. So again, I'm going to say OK. That's going to give me my pink outline. I'll turn off the mesh. I can see exactly where my column's at. Instead of doing this all over the place, this time I'm going to create a center line. Using rectangles, I'm going to repeat the steps that I did, and then mirror that over to the opposite side. So we can clearly see where our rectangles are at. Here, 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 here. Then likewise up here. There's several different rectangles as well. Rectangles, by the way, the most underused modeling tool there is, but they are super useful when you use them correctly. So again, I'm pretty happy with that. I'll turn on my mesh just to make sure I have every area covered, and it looks like I do. Good, so I'll go ahead and turn that off again, and then it's just a matter of sizing these up. Looks like on this top one here, this is my stop point. I don't need to go any farther than this. So this area here, out, and again, I'm going to only do one side of this, and then I'm going to mirror it over to the opposite side. So this will be a totally functioning solid body once we're done. Good for representational modeling, or good for anything really. If you want to redesign, modify, or add on to this structure, you can now do that with the solid body that we're going to create here in a second. So again, I'm just snapping to the polyline that's representing the mesh underneath. Bring this out, bring this down, and just kind of doing this over and over and over again. Perfect. There is no easy button for modeling, but this gets us really, really close. That looks pretty good, and I'm almost done. I only have about 3 more rectangles here to go, and then we can take a look and see how well we modeled. Well, I should say after we're done mirroring it over to the opposite side and doing all the cleanup that we need to do. Right there. All the way down here, and we'll turn on our mesh again just to make sure this is what we want, and it is. Good. So I'll bring this out, and I'll turn on my solid body really quick just to take a look at where that's at. And it looks like I have a little bit more to go. What I miss? Oh, that looks okay. It's just this area of concern, so I'll go ahead and take this box all the way out. Turn off my mesh real quick. Come on now. Drag that all the way down through my model. Okay, And then once again, it's just a matter of trimming and cleaning up. So I'm going to cut away all this stuff here. Get rid of all of the stuff on the back. I don't need any of it. Then take a look at the pigtails real quick. Cut that one away. Cut that area away. Let's see. Oh, there's one back here. Don't need that one. And then also I'll have to extend this out past my solid model here as well. So again, trimming away. Trim this all away. Good. Clean up the pigtails. Here. Here. Cool. And then we'll drag that out past the model. So I'll zoom out a little bit. Go to resize. Grab this end and pull it all the way out. Great. Now I just need to mirror this over to the other side. To do that, I'll use the mirror option. I'll select the symmetry line, and then I'll select all the entities that I have on here. That looks pretty good, and I'll go ahead and say OK. Last but not least, I need to create an outer rectangle to represent the outer edges. And then once again, I'll resize these endpoints to go past the rectangle here. Do a power trim, and then last but not least, a corner trim, so that I have two cutting tools instead of one. Perfect. So now we have this, and now all we have to do is extrude through this block to finish up our model. So again, I'll exit sketch. I'll go into model, extrude, then I'll say through all. In the opposite direction, I will go through all as well. And this time down here, I will choose cut. And I'll say OK. And there's our column. Turn on the mesh, see how we did with the mesh. That looks great. So here you have a column in about under 15 minutes that you can continue on modeling with. Maybe add more detail to this building if you like. You can add something down to the street, put in a light on this column or whatever you need to do. And with that, I'll go ahead and hand it back over to you guys. Thank you very much.
Thanks, Jeff. Well, it looks like we've gone over our budget, our time budget, by about 7 minutes for this segment. So I still would like to get in some Q&A, or some answers to some of the questions. But just so that everyone knows, the material that we intended to cover has been covered, and if you need to bow out of the webinar, now it's okay. And we will forward frequently asked questions to those who registered. So with that, let's start the questions. Let's see. Relative to the scanner, I guess this is for you, Anton. How does the ray do in direct sunlight? I guess there are a couple other questions here regarding, anything to explain about the use of the tool out of doors.
In terms of scanning in direct sunlight, the ray does a fantastic job of that task. It is specifically designed that way to be able to filter out noise and be able to record surfaces illuminated by direct sunlight. So that is not a problem at all.
Okay. The next question, also scanner related. Anton, you mentioned that the ray can be used as a reverse engineering scanner, but it is a hemispheric LiDAR scanner. How does that work? What gives the ray the ability to act/be used as a reverse engineering scanner? Whew, mouthful. Over to you, Anton.
So unlike most traditional LiDAR scanners, the ray was specifically engineered to be able to generate data sets for reverse engineering. So it has two capabilities that other LiDAR scanners don't possess to the same degree. Namely, it has a lot better data density. You get a lot denser data sets at shorter ranges, which give you very good detailed definition for reverse engineering. And secondly, it has a much cleaner data set, therefore increasing the accuracy and the quality of those surfaces. This is why the ray is a very good scanner specifically for reverse engineering, unlike most of its competition in the LiDAR field.
The next scanner question, let's see. How does the ray do with reflective objects?
reflective specular surfaces are notoriously hard to scan with all LiDAR scanners or all laser scanners in general, particularly because they reflect a lot of the light that is used in measurements away from the scanner. It never returns to the measurement device, so it's harder to make measurements with that light, or alternatively, if the surface is pointed at the scanner, it returns too much information, too much intensity. In order to mitigate that, we have a special high sensitivity mode for the ray that allows you to scan a lot more specular reflective surfaces than you can with a traditional LiDAR scanner. And of course, if all else fails, you can always spray the surface with some sort of a glare reducing spray like you do with any other LiDAR scanner.
All right, moving on to questions about the software. Let's see, what file types can this data be exported in? And that's over for you, Jeff.
So there are many file types you can export out of DesignX. The most common file types for meshes are STLs, OBJs, and PLYs.
Okay. Next, in software, how long would it take to reverse engineer the entire building?
Good question. It would largely depend on the user, but if I were to reverse engineer that building, I would say it would take me about 2 hours, depending on what complexity I needed to add it in, or what I could get away with, or what I didn't need to add in. But it would take about 2 hours for me.
Here's one that's a little more technical. Someone sounds like they have some experience with LiDAR scanners. I have 2 sets of scans. How do I put them together?
So this is what scares a lot of people about scanning. Basically, they're going to scan one side of an object and then the opposite side of an object, and they need to have enough overlapping geometry that's unique enough for the computer to say, this area belongs with this area.
All right. And then the last question we have time for here, do I always need to convert the point clouds to mesh to reverse engineer the scan?
Nope. DesignX works equally well in reverse engineering point clouds as it does mesh.
Well, this concludes the webinar in LiDAR scanning and reverse engineering with Geomagic's DesignX by Indicate Technologies. Please join us for the rest of the segments in the Digitize for Design and Inspection webinar series. And remember, with Indicate Technologies, when producing high-quality parts at the lowest possible cost is your mission, making solutions easy to deploy, manage, and scale is ours. Thank you for joining us, and have a great day.